perfectly fine. If you want to use that method, your work just has to match the problem. But I'm not going to show you two different methods when one method is perfectly plenty. It's enough. Nobody reminded me to get before. Like last Thursday when I showed up over here, I didn't have my keys. I go and tell my wife, why didn't you tell me to bring my keys? And then last Wednesday when I forgot my sandwich, why didn't you remind me to bring my sandwich? So point slope formula is like this: y minus y sub 1 is equal to the slope m times x minus x sub 1. That's the one that we're not going to use. The thing that I'm going to teach you with, and the answer form that I want you to do, write the equation in slope-intercept form. Y equals mx plus b. But this is your bread and butter. Slope-intercept. Where m is the slope and b is your y-intercept. That means it's where it crosses the y-axis. So that's what I'll use when we do question number 2. And then I put down here for 4 and 5, because there's 5 ways. Those are special cases. And we're going to cover those today, because that will put in the questions down here at the bottom. Those right there. Those will be bonus questions on your quiz. Not all 4 of them. I'm just going to ask you one. But all 4 of these are examples of what I could ask. Right? We are going to graph 4x minus 10y equals 20. Now, the directions that you see right here, basically almost identical. The camera. Going to be exactly what you're going to see every time you take a quiz, every time you make a mistake, take a test, those kinds of things. Make sure you read and follow directions. Simplify, reduce your final answer to the lowest terms. Fractions. Reduce your fractions to the lowest terms. Okay, it's going to make your life easier. No decimals. I put this on every quiz and every test, and I still get in the middle of the semester. At the end of the semester, people put decimals. Only if the directions tell you, that's when you put decimals. Write your final solution in the given space when provided. Right now, we don't have one of those. You'll see it later. You must show appropriate work to receive full credit. Work must be neat, legible, and in the appropriate boxes. So no scratch paper. You do all your work in these boxes because that's what I'm going to grade is what's in the boxes. When students use scratch paper, they don't put the problems in order. They don't even number the problems. They say, see the back, and they put see the back on like 4 different things. I don't know which one is which. So you'll get used to it. Everybody does. And the boxes are big. Okay. Please remember quizzes, they should be done in pencil. They don't have to. Tests have to be done in pencil. Quizzes should be done with a pencil, so mistakes may easily be erased. Don't cross out or scribble out mistakes. It's always count because If you want partial credit, I have to grade what you wrote. All right. Good. So when you first learn how to graph, usually you made a table and you pick numbers and randomly plug them in for an X and you solve for the Y, or you pick the number, you plug it in for the Y and you solve for the X. That's perfectly still fun, but it's not as efficient when you have to do a whole bunch of it, and it's not going to help you because when you get to section 3.6, we're going to learn something about, this is going to be for some of you the new stuff, what this means, functions, f of x. And when you have a function notation, it's just a notation. It's a different way to write something, that's all. Math is a language. And if we can spell there 5 different kinds of ways, in math we have a different way to write certain types of things to create some type of, and it's not easier, but a different approach. A different approach. Until this notation came around in the late 16, early 1700s, thanks to Leonard Euler, mathematics took on a whole new leap. Just a simple notation, a way of communicating, that's all. But the bottom line is, the way you want to graph a line is you need 2 points. And you draw the line through those 2 points. Now, the best thing to do is solve for the y. Rewrite if necessary in slope-intercept form. Y equals mx plus b. Because you need 2 points. Now, when you have it in slope-intercept form, you automatically have one of the points. You have the y-intercept. That's what the b is. B is going to tell you the y-intercept. It tells you where on the y-axis the graph crosses. Okay, that's where it's going to cross it. The slope is the rise over the run of the line. It tells you how to go from one point to the next point. It's like having directions from one place to another place. Tells you how to get there. Rise is up and down. Run is across. Rise over run. So this is where the previous class, Algebra 1, is important. Knowing how to solve an equation for a variable. So we have to undo what's being done to that y. We want to get that y, because that's what this slope-intercept form is. You got to get that y all by itself. What does the y equal? That's it. Get everything else on the other side. The first thing you do is you undo addition or subtraction. The last thing you're going to do is multiplication or division. It's like running the order of operations in reverse. Okay. So we have to get the 4x over to the right side. Since that's a positive 4x, you would subtract 4x from both sides, minus 4x. You want to undo a positive 4x, so you subtract 4x from both sides. Now, here is one of the killers on quizzes, tests, so forth. The next thing you do is bring down what you got. 4x minus 4x, that's a 0. But what you have right here is a negative 10y equals. And what I see is people forget to put the negative 10y. Not in the frame. They forget to bring the negative with the 10y. So you make sure you keep track of your signs. Signs matter. Signs are the killer. Okay? What makes a negative more angry? When you do fine. You ever have any friends that are always negative? And if they don't get invited along, doesn't that piss them off even more? Until the point where you just don't want to be around them anymore. Then that just pisses them off even more. Don't mess with the negatives. Okay? This is going to bug some of you. I don't care. This is going to bug some of you, but it's going to help you. On the right side, I know you want to put 16. Some of you will. I know some of you, because I've seen it every semester since I've been teaching. When you subtract the 4x, laziness happens and you don't put the x with it. And you accidentally do 20 minus 4, and that's 16. No, it's an x. Okay, little tiny details matter. Now, 20 minus 4x, they're not like terms, so you can't do any subtraction with that. So what you want to put over here, remember what you're trying to make. You're trying to make y equals mx plus the constant. The variable x should be in front of the constant. X and then the constant. So I know some of you are going to want to put, that's a positive 20, and then you have a minus 4x, 20 minus 4, because that's technically what it is. That's not wrong. But down here, when you go 20 minus 4x, and you're trying to match up the slope and the y-intercept, they're in the wrong place. Remember, it's like looking at a police lineup, and you're trying to pick out who stole your backpack, and they're standing in the wrong place. Trying to pick them out. You can't figure out who's who unless they're in the right order. So, on this right-hand side, the x should go first. It's a negative 4x. Don't forget the sign. And that's a positive 20, plus 20. Now, can you put 20 minus 4x and then switch it? X would go first. If you do that, just remember it's a negative 4x. And that's a positive 20, so it would go plus 20. If you switch the order. Okay, it's perfectly fine. You can switch the order. Addition is commutative. And again, that's something from the previous class. Okay. Now, we don't care about negative 10y. We want positive y. So since it's multiplication, you need to undo that multiplication. It's being multiplied by negative 10. Don't write this down. It's multiplied by negative 10, so you have to divide this by negative 10. And again, here's where the mistake will happen. Some of you are going to, because you've been taught to divide the whole thing by negative 10. That's not wrong. but it's not going to help you. Because what you want is an individual mx and then a plus b. You want them separated. You got to keep them separated. That's an offspring. No? It's a band from the 90s. Some of you probably won't. So here's the deal. If you divide one term by -10, everybody gets divided by -10. It's the same thing. If you divide one, you divide all. Now you can just simplify each individual term. This is y, because the -10 reduce, equals. Now, a negative over a negative, make sure you fix your signs, a negative divided by negative is a positive. Negative over a negative is a positive. Simplify 4 over 10. The common factor is a 2, so that's 2 times 2 over, this is 2 times 5. And then you have the x. A positive over a negative, that's a negative. 20 over 10. And I'm just going to, 10 goes into 22 times, but I'm going to do the work. This is 10 times 2, 10 times 1. So you can see what I'm about to reduce. You don't have to show me that second part. I'll show you what you can get away with. That's fine. So now, right here, y equals, these 2's are going to reduce, and you're left with 2/5 times x minus the 10's reduce. 2 divided by 1 is just 2. Now, just so you can see, right here, that y equals -4 over -10, x, and then plus 20 over -10. You're perfectly fine if you just show me this. Negative over negative, that's positive. You can go 2 goes into 4 twice, 2 goes to 10 5 times. So that's positive 2/5 x. A positive over a negative is a negative. 10 goes into 22 times, so -2. You don't have to show me the factors, but if you're struggling with reducing, then show the factors. So I will always show, because somebody's going to say, how'd you get this? If I just start crossing things out, I will always show what crossed out, okay? All right. So now we do the police lineup. We need the slope and the y-intercept. So in this lineup, see how it matches up. What's the coefficient in front of the x? What's the slope? 2 over 5. And then the plus b. What would b have to equal in order for this to be a -2? This would have to be plus, because it's plus, and the way you get a -2 is because you're adding a -2. So if you see a positive, then the slope is, the y-intercept is a positive. When you see a minus, it's a negative, -2. Okay. So this is what I'm working with. I got a slope of 2 over 5 and a y-intercept of -2. Okay. So we find the slope and the y-intercept. You're going to plot and label the y-intercept. Okay. I will be saying that all semester. But you got to label what you're graphing, always. Just label the points that end up, what you're drawing through. If it's on the X or the Y axis, if it's on one of the axes. On the Y axis, right here is -2. You can label it with just a single number. You don't have to show me an ordered pair. Now, some of you can, you can write an ordered pair, and some of you will try to write an ordered pair. Here's why I let you off the hook and don't, make you write an ordered pair. You know it's a -2, but I've seen people do this. -2, 0, and they put it in the wrong spot. -2, 0 is up here. If X is -2 and Y is 0, then that's the point you just called it. This right here on the Y axis, X is a 0, Y is a -2. If you write something down that's wrong, so if you label it incorrectly, you'll lose 1 point. So that's why if it's on an axis, you are perfectly fine with just that's -2. Okay, that way there's no confusion. If it's the origin, where's the origin at? Right where they intersect, right here. So right here, X is 0 and Y is 0, 0, 0. That gets kind of messy. The origin is the only point. I don't need you to label it at all. We're all going to know it's at 0, 0. Because it's just a little messy to just put even a single 0. Where should you put it? So if you have to put a point at the origin, don't worry about labeling if it's on the origin. Okay. All right. So there's 1 point. Now the slope is directions on how to get to the next point. It's like, and now that everybody has a phone with GPS on it, you don't do this anymore. But growing up back in the old days, when we were lost in a city that we had no idea about, you pull over to a gas station. Can you tell me how to get to? Craziest town I've ever been to when I was coaching basketball, when my brother was coaching and we had to go to Dinuba. The streets in Dinuba do not intersect at right angles, like normal intersections. The streets in Dinuba intersect with obtuse and acute angles because the streets run parallel to the train tracks. So it's a little confusing in Dinuba. So I remember I would pull over to the gas station. Where's the high school? The high school is go over 2 blocks and then turn right and go over 5 blocks. It's directions on how to go from one point, from one place to the next place. It's a +2. The rise is 2, the run is 5. If it's positive, you go up. If it's positive on an X, you go to the right. If it's a negative Y, you go down. If it's a negative X, you go left. And I'm going the wrong way. You go, all right. Yeah. If it's a positive, you go up. If it's negative, you go left. Okay. If it's positive or negative, you go down. Positive to the right. It's X. So positive Y up, negative Y down, positive X to the right, positive X to the left, or negative X to the left. I don't mean to blaspheme, but I just feel like I blessed it. I don't have that. So from this point, and that's your starting point. You're like, you follow the treasure map. Walk 2 paces this way. So from here, 1, 2, and then turn right because you're going positive, and walk 5 paces to the right. 1, 2, 3, 4, 5. That's the next point on the line. And you're going to label it. And if you label it with an ordered pair, X is a 5 and Y is a 0. And that, again, I see students mix that up, put it backwards. So if it's on the X axis, I can just label that with a 5. So we plot and label the y-intercept, and then you use the slope, the rise over the run as directions to get to the next point. And you're going to plot and label that. And you're going to take a straight edge. And draw your line. And one other thing here, don't forget arrowheads. Don't forget the arrows, because lines go on forever. So when you draw your line, make sure you put arrows in both directions. Straight edge. Right there. Arrows. And that's how you graph. Now the homework, here's the problem. You're using the mouse to do your graphing. So you're not doing the graphing by hand. And then when you show up for a quiz, test, etc., now you got to graph by hand. So if you don't practice graphing by hand and you get to the quiz or the test, it's like, wait a second. So you have a graph paper, try doing the problem that you're doing for homework on paper first, and then do it on the homework. Now I want to point something out to you. We have a slope of +2/5. Is that the same if I wrote it -2/5? Would that give me the same slope? Yes or no? Yes, it will. Because a negative divided by a negative is a positive. So this is equal to that. The negatives just aren't reduced. Okay? The negatives are not reduced. I just want to point out this. How many points are on a line? Well, it takes 2 to draw a line, but how many points exist on the line itself? An infinite number of points. There's an infinite number of points. Remember, I can keep up, continue going. I can go up 2 and over 5 more. Now, if I go over 5 more, 5 over would put me at 10. If I go up 2, then I would be at a y2. I would be right about here, where this would be 10, 2. That's on the line. And you could go up 2 and over 5 and up 2 over 5. It's like a staircase. Because that's the slope of the line. It is always going to go up 2 and over 5, up 2 and over 5, up 2 and over 5. Because the arrows means it goes on in that direction forever. And this, that's the definition of a line. -2 over -5. I can go down 2 and to the left 5. And it's on the line. If I go down 2 and left 5, then this point right here, x is -5 and y is -4. Because down here, this, if I start at -2 and I go down 2 more, Now I'm at a y value of -4. Now here's the deal. What do all these ordered pairs represent? Well, look at where they came from. They came from this equation. They came out of this problem right here. That means all of those ordered pairs are solutions to this equation. For instance, this is 5, 0. Right here, this is 5, 0. Five, 0 is on the line, so 5, 0 should solve this problem. That means x is 5, and the y is a 0. If I plug it into the x and the y right here, 4 times 5, minus 10 times y is a 0, I'm supposed to get 20. 4 times 5 is 20, minus 10 times 0 is 0. 20 minus 0, I get 20 equals 20. It solves the problem. If I kept going, 10, 2. 10, 2 is on the line. That means if I plug 10 in for x and y is a 2, it's going to make this equation work. 4 times x is now 4 times x is a 10. Minus 10 times y, minus 10 times a 2 is supposed to equal 20. 4 times 10 is 40, minus 10 times 2 is 20. 40 minus 20 works, because that point is on the line. This -5, -4, one last one. -5, -4 is supposed to solve this equation. So that means when I plug in x is -5 and y is a -4, so 4 times x, 4 times -5, minus 10 times y is -4. It's supposed to make 0. Or sorry, 20. Positive times a negative is a negative. 4 times 5 is 20. A negative times a negative. A negative times a negative is a positive. That's going to be a plus 10 times 4. That's 40. It's supposed to equal 20. -20 plus 40 is positive 20. So that point's on the line. And those are just the ordered pairs that are nice numbers. Those are the ordered pairs that are integers. No decimals and no fractions. This is on the line. I can just go up 1 and go over 2.5. So instead of going up 2 and over 5, let's go halfway. Instead of going up 2, let's go halfway. Let's go up 1. Instead of going over 5, let's go half of 5 and go 2.5. 5 over 2. That would be on the line because the ratio is the same. Okay. You could cut it up into thirds and it would still be on the line. As long as you divide the rise and the run both by a 3. But there's an infinite number of points you can find. Okay. Don't graph the order pairs that are fractions because that's why I gave you a grid. I promised every single question that I have you graph will nicely fit in that -7 to 7 x and y axis You don't have to count by twos and change the scale. You don't have to plot fractions everywhere, anywhere. It'll work out nicely. Or, you know, I always make sure I write questions that work out nicely when you have to. Okay. Now, if you're in my Math 3A class, I made this graph paper for them. This is what they got to do. 18 by 18. Because they got more stuff. That's all. Any questions? Next one. Next one. Write the equation of the line in the slope intercept form, y equals mx plus b. So we're going to do this step by step, and I'm going to show you one step at a time how to write the equation of the line. And since the directions for writing the equation of the line are going to be that every single time, and I'm going to be, again, honest and straightforward, we're doing it in this chapter, going to do it again in the next chapter, the next unit, chapter 8 and 9. So it's not going away. Okay? Step 1, find the slope. Find the slope. You can't write the equation of the line unless you know what the slope is. That's the first thing you got to figure out. Sometimes it's just going to be given to you. Okay? Sometimes it'll just be given to you. Other times you're going to have to figure it out. In this problem, we do not have it given to us. So we have to find it on our own. Because we have 2 points, we have 2 ordered pairs. Let's not forget, you can always find the slope by using the slope formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. First part of the homework. Okay. This is a review sheet for your test. The first 4 problems on the review sheet find the slope through the following 2 pairs of points. So it is just like the homework at the very beginning, find slope. right here. Remember, tests are not open node. You have to know this formula. Rise is the Y's. Run is your X's. X's kind of look like it's somebody with, running along, you get little feet right here. And they're running along. That's rise over the run. Rise is the Y's. Run is the X's. X's are running along. But it's the difference in the Y coordinates divided by the difference in the X coordinates. Okay? When you compare this review sheet to the actual test, I give you 4 on the review sheet. I'm only going to ask you 3 on the test. No surprises. No surprises. Okay? Showing you. Very transparent. I need the slope. So since I have 2 ordered pairs, I'm going to need slope equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So my slope here, it doesn't matter which y you start with. I know that everybody wants to go, hey, that's my y sub 2 because it's the second order pair. That's perfectly fine. But remember, I could have asked you this problem and I could have written -15, -5 first, and then put 5, -9 second. Right? I mean, I didn't have to put them in the first order. I could have written them in the second order. So it doesn't matter which y you put first. What matters is this. If you choose to start with -5, that y, so -5 minus this one. Now remember, be careful with negatives. Minus parentheses, that's a -9. So this y minus that one. Over. If you start with this y in the numerator, you gotta start the denominator with its ordered pair little buddy right here. You gotta start with this x. You can't start over here. I know you were just here. Hey, I just used that -9. Why go all the way down over here and get this? I'll just use this one. No. That's my y sub 2. This is my x sub 2. This is what you have to do first in the denominator. -15 minus that 5. Simplify your extra negative. This is -5. 2 consecutive negatives make that a +9. Over -15 minus 5 is -20. 15 negatives and 5 more negatives combine and make 20 negatives. You spend $15, you spend 5 more dollars, you spend $15. Brady gets thrown for a loss of 15, another loss of 5. He's first down and or third down and or be -30 because of the 10 yards to begin with, but he's for a loss right now of -20. -5 plus 9 is +4. -20. Always simplify. Always reduce your fractions. So first of all, a positive divided by a negative would be a negative. This is 4 times 1 over 4 times 5. The 4's reduce, so we end up with a -1/5. Be real careful. I've seen students put 5 over 1. They know it's 1/5, but they still just write 5. Yeah, you have to have that 1 on that. Just to prove a point. Because on when I write the answer key, I always do it the other way too, so I can check their work in case somebody does it this way. I'll start with this y. So if I start with this -9, that y, -9, minus this y on -5 over this x, since I started with this y, I gotta start with this x now, 5, minus this x, which is now a -15. Consecutive negatives become positives. This is -9 plus 5. This is 5 plus 15. -9 plus 5 is -4. -5 plus 15 is +20. A negative over a positive is a negative. 4 times 1 over 4 times 5. This is -1/5. Same slope. So it doesn't matter if I start with this y first, or if I start with that y first. As long as if I start with this y in the numerator, I have to start with this x in the denominator. If I start with this y in the numerator, I have to start with the 5 in the denominator. You can't crisscross that. That's all. That's what you got to do. Here's the thing. So step 1, find the slope. Because you're making a puzzle, you got to figure out what m and the v are. So the first thing you do is figure out what is m equal, and we have slope equals -1/5. And again, real quick, take a look. The first time I did it, it was 4 over -20. Positive over a negative is a -1/5. The second time I did it, I got -4 over +20. A negative over a positive is just a -1/5. So I want to make sure you realize -1/5 is exactly the same as a -1/5, which is exactly the same as a +1 over a -5. As long as you have one negative, it doesn't matter if it's in the numerator, the denominator, or just out in front. It's a negative slope. Okay? As long as there's one negative, it doesn't matter where it is. And that's going to be important, again, when you do a graphing problem. Find the slope. I got my slope. Step 2. Is it a special case? Now, we haven't talked about the special cases yet, so we're going to come back to that because that's the other examples. So leave a little room here to come back to the special cases. Leave a little room after step 2. Step 3. And this is something that I will always do. I'm going to write down the formula. When you got to work a puzzle, you want to have the box with the picture on it in front of you so you know what you're working with, so you know what you're plugging into. I know I'm supposed to plug into y equals mx plus b. I know that's what stuff is, everything's going to go into. So what I need to know is, okay, I've got my slope, so now this is what I'm going to plug it into. So the first next thing you do, plug in that slope, substitute the slope. Plug it in. One thing at a time. So y equals -1/5 x. We still don't know what b is, but we're halfway done. And again, it's going slowly because I'm walking you through all the steps. All we need to do now to finish this off is to figure out what's the B, what's the Y-intercept. So to figure out this variable, this B right here, you have three variables right now. You have a Y, you have an X, and you have this unknown B. When you have an equation with three things that you don't know, in order to figure out one of them, what you need is to plug something in for the other two. You can figure out one variable if you know what the other two are. If I only knew an X and a Y that was on this line, then I could plug in the X and Y and I could solve the B. Well, they gave me this X and Y that's supposed to be on the line because that's what it goes through. And I also have this one. This is also on the line because this is what it goes through. So step 5. Step 5. Choose an X, Y, and substitute and solve for B. So you tell me, do you want me to plug in the first order pair or the second one? The second one? Okay. And again, when I do the answer key, I write it and I do the work for both of them so I can see, somebody does this one or somebody does the other one. So that means if I'm going to use -15 comma -5, I'm going to let the X equal -15 and the Y is going to be a -5. So going in for Y, -5 equals -1/5 times X, which is -15. And remember, you're solving for B, so don't forget to bring that down, plus B. So we plug in what we do know, so we can solve for what we don't know. What do you have and what do you want? I want B. I have an ordered pair. I have a couple of ordered pairs. Before you solve, simplify. And again, I promise I will give you nice numbers. I will make it so the slope a nice slope, and the ordered pairs that you have to plug in reduce nicely, so you don't have to worry about adding or subtracting fractions from either side. It's going to work out nicely. Watch. -5 equals a negative times a negative is a positive. 1/5 times 15, this is 15 over 1. So 5 goes into 15 3 times. So it's -1 times -3, and that's +3 plus B. So one more time over here on the side. -5 equals -1/5 times -15 plus B. This is -15 over 1. So what you have is -5 equals a negative times a negative is a positive. When you multiply fractions, you multiply straight across. So it's 1 times 15 over 5 times 1 plus B. So -5 equals 15 divided by 5. So 5 times 3 over 5 times 1. The 5 reduced. So -5 equals 3 divided by 1 is just 3. Now to solve for the b. So that's the last piece of the puzzle that I need. I just need to put the 3 over on the left side, so I subtract 3 from those. Because it's a positive 3, I subtract it. -5 minus 3 is -8. And that's the missing y-intercept. And so the last step on the how to write the equation of the line, substitute the b into y equals mx plus b. Make sure it's reduced. Make sure all your fractions, everything is nicely reduced. So here's where I left off. Y equals -1/5 x. I didn't know what b was. I just found out that it was a -8. So now I'm just going to finish this off. Y equals -1/5 x. Plus -8 is just -8. So when we come back from break, we will work on our special cases, finish the other 4 examples, and I will go over what's going to happen on the calendar. So come on back at, let's just call it 9:50. Okay, so we are going to finish 3, 4, 3, 5 because we're not going to finish all today. We'll finish it on Thursday. We're going to take a practice quiz at the end of class on Thursday. Just a practice quiz is not going to count against you. So the quiz that you were going to take that was going to count is now just a practice one, and it's not going to count. Just so you can try. You get a chance, you're going to give it a shot. There. Now, if we can, we might, if we start, question mark here, 3.6, we might. If not, sorry. Next Tuesday, we're going to lecture on 3.6, and this is when the actual 3.4, 3.5 quiz will be. Now, we will have a warm-up, just like we're doing right now, but we're not going to spend as much time on it, of course. I'm using this warm-up to actually do the teaching. Some good examples that are not necessarily just me lecturing with problems that don't relate, because this is what you're going to have to be able to do in your quiz and on your test and even in the homework. So they're good examples to basically review with and to teach with. We will do a warm-up that's like your quiz at the beginning of class, and then you'll take your quiz at the end of class next Tuesday. Okay? We'll get them back on Thursday. We'll finish up 3.6 on Thursday and we get the review sheet. Making sure that it's actually February 1st. Last semester, I did not have my calendar at all. We'll review chapter 3. And then Thursday the 3rd, chapter 3 test. Okay. So the quiz is next Tuesday, not Thursday. And it's going to look just like this. One graphing problem. One, write the equation of a line if I give you 2 points problem. And then a bonus question, special cases, which is what we're going to do right now. So before I can go over special cases, we have to talk about slope, the four different kinds of slope. Okay, the first two we've already dealt with. If the slope is greater than 0. So first thing I'm going to do is I'm going to speak math with you. Greater than 0. What kind of values are greater than 0? Positive numbers. Anything greater than a 0 is a positive. So if the slope is positive, so it looks like this. We say that the line rises as you go from left to right. It's always about left to right. So as you look at the x coordinates from the left to the right, the y's are getting bigger. It rises. As x gets bigger, so like this is -5, -4, -3, -2, -1, 0, x is getting bigger. 1, 2, 3, 4, 5. As x gets bigger, the y's get bigger. -3, -2, -1, and then over here, 1, 2, 3, 4. As x gets bigger, y gets bigger. When you get a little further in mathematics, we would say it's increasing. As x increases, y increases. So that's a picture of something that's increasing. And that's what we care about when, when students ask me, when am I ever going to have to use this? I really can't tell you a lot until, when they do that, I go, hey, how about this word problem? Well, I don't want to do word problems. I like them. But you just ask, when am I ever going to do this? A word problem gives you a real world example of how math applies. But I don't like word problems. But you just, until you get past this class, it's very difficult to show you how this applies. When you take a stats class, it really brings everything into perspective. If you go into STEM and you're doing trigonometry or Math 3A and do college algebra, it really shows you the applications of what you're dealing with, what you're learning. Math 45. I don't know why that class does not take off better here. It's one of the most interesting classes I've ever taught because it really shows you how math applies in all sorts of things. And the math isn't hard, it really isn't. But it's a college level transfer class, Math 45. And you study bits and pieces of all sorts of applications, from networking to how math is used and how we count votes and how power structures are used. When you do committees and how voting happens in committees, voting really doesn't matter. It's how you count the votes that matter. The Electoral College. Okay. Your vote in California, depending upon who you vote for, usually is going to go to the Democratic candidate because California has always demonstrated that it's going to be a Democratic support, blue state. Likewise, if you go to Omaha, Nebraska, it's going to be a red state. So if you're a Democrat living in Nebraska, your vote really is going to count. It's going to go to a Republican candidate. Because that's how the electoral college works. No matter if you vote for, it's all the votes from that state go to the red candidate, all the votes from the state usually go to the blue candidate. But that's how the votes have been counted until there is an amendment that says we're going to do it differently. But that's what we do in Math 45 is we study how these things actually happen. Okay, you do a little bit of stats, you do a little bit of probability, you do a little bit of everything. Okay? Anyway, can't really do this until we get past this. In calculus is based on when do things increase or decrease. When can something reach a maximum output with a minimal amount of input? Okay, maximize sales, you have to minimize production. Because that's what life is about. Money. It looks like this from left to right, it rises. If it looks like this, if the slope is less than 0, greater, less than. If it's less than 0, if the slope is negative, this, from left to right, we say that this line falls from the left to the right. That's how it's described. It falls. So if we go from here to the right, the x's continually to get increased. The x's are getting bigger, but the y's are decreasing. Positive 5, 4, 3, 2, negative 1, negative 2, negative 3, just they decrease. Greater than 0, less than 0, what are we missing? Equal to 0. Numbers that are greater than, less than, and equal to. So if the slope equals 0. Oh, the line's going to look like this. So think about it. Positive, negative. So it's going from positive numbers to negative numbers. Doesn't 0 happen between the positives and the negatives? So positive, tell me when you think of 0. That would be 0. What kind of line is this called? A horizontal line. When it goes from left to right straight across, that's a horizontal line. So if the line's horizontal, you would have a 0 slope. Now, people get confused about which one is horizontal versus the other. Horizontal. When you make that capital H, guess what you got right here? You have a picture of a horizontal line that makes the crossbar in that, touchdown upright, the goalpost. left to right. Horizontal, left to right. Okay. There's one more. Well, obviously, if you have horizontal, you got to have vertical. The horizontal is left to right. What's vertical? Straight up and down. So vertical line looks like this. That would be a vertical line. Now, I'm not going to tell you about the slope yet, because I want to show you why. But vertical, the V is like an arrow that points down, so the other one must point up. Vertical, up and down. So that way you can remember which one is which. Okay. The reason why this slope is positive, if I pick any 2 points on this line, any, and I just do a simple, I'm not going to label the order pair. If I just do a simple rise, you know what, I'm going to be right in the way. If I just calculate this slope using rise over rise, not with numbers, but just rise over rise. The difference in y divided by the difference in x. So if I go from left to right, which is usually how you should go, and we do the rise. To go from this point to that point, the rise is up. The rise is a positive change. So the rise is a positive. And then the run is to the right. So the run is a positive because you're going to the right. The change in the x's is a positive. So when you calculate the slope, you have a positive divided by a positive. And that's why the slope of something that looks like this is always positive. If we go from right to left, because when I gave you the slope formula, I told you it doesn't matter which point you plug in first. You know, I hope you don't graph the points to do the slope, but it doesn't matter which one you plug in. So that's going from left to right. If I started here and went this way to get to this point, the rise, you have to go down for the rise. So the rise is a negative number because you have to go down. And the run, you have to go to the left. The left is a negative direction. So that's a negative run. So the rise is negative and the run is negative. If you go from right to left, it's a negative over a negative. And that is also going to be a positive slope, no matter how you get from one point to the other. Because technically, when we went to see my brother's basketball games in Dinuba, we would have to get from home to Dinuba, and we would have to go from Dinuba back to home. Okay? The slope's the same either way. Okay? It's going to be positive no matter what. Because we always beat Dinuba. Positive. We do the other one. This is going to be a negative slope. Because again, when you do rise over run, and I just go from here to here. So if I go from left to right, I have to go down first, and that's a negative direction. So the rise is a negative, and the run is to the right, and the run is a positive. So a negative over a positive, that's why we get a negative slope when it looks like this every time, no matter what. I don't even have any numbers there, and it's going to be a negative slope because of directions. And if we go the other way, right to left, the rise would go up, so that would be a positive slope. But the run is going to go left, and that's a negative direction, so the run is a negative. And a positive divided by a negative is a negative slope. Always. So if the line falls from left to right, it's a negative slope. Now, that slope is 0. Now, for this one, I do have to put some numbers on here so you can actually see what's going on. So I'm going to label this y coordinate. I'm just going to call it 5. And then this maybe is -1, so that's -1, +5. Over here, let's make that -4. So that's -4, +5. Over here, let's call this 3. So this is 3, +5. And over here, let's call this 37. So that right there is, not to scale, 37, +5. Okay. What do you see that keeps repeating itself? The 5. The y coordinate is the 5 all the way across. That's what keeps it horizontal, is because the y is the same number. Don't forget that. We're going to come back to that. But y is the same number, and that's why it's horizontal, because if y changes, now it's got a slope going like this or like this, and somewhere something different. But if y is the same number, then it has to go straight across. Okay. Now, slope, rise over run. So if I do my slope right here, if I start at this point, and let's go to this point. So the rise, the y coordinate, that's a 5. And over here, that's a 5. So if I go from this y to that y, how much did it change up and down? From 5 to a 5. How big is that change? It's the same, so what number is it? 0. It didn't change at all. It's 0. It didn't change at all. The rise is 0. But the run is going to be something. This is -4. And all the way to 3 is how much? How far is it from -4 to the 0? 4. And then how far is it from 0 to the 3? And then so -4 to the 3 is going to be 7. Distance is always positive. So from that -4 to the 0 is a total of 4. And then the 0 to the 3 is 3 more. So a total distance of 7. So the rise is 0 and the run is 7. This is what I told you last week. If you have 0 divided by a number, 0 in the numerator, any number except 0, any number going into 0 is always 0. So 7 goes into 0 times. Seven goes into 0 times. So that's why the slope of this horizontal line is going to be a 0. No matter which point to use, no matter where the horizontal line would be, the y coordinates would be the same. Remember, slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You subtract the y's in the numerator. In a horizontal line, the y's are the same number. So in the numerator, it's always going to be a 5 minus a 5, no matter where you are. It's always going to be. And so in the numerator, if you have 5 minus 5, you're always going to have 0 over something. So it's going to be 0 on a horizontal line. Slope is 0. And slope is 0. From -1 to 37 over 5, the rise. From 5 to 5, that's a 0. From -1 to 37, that's a change of 38. 38 goes into 0 times. Slope is 0. Horizontal line, slope is 0. Vertical. Let's make this a 4. So up here, x would be a 4, y might be a 10. This might be x is a 4, y is a 3. Down here, this could be x is a 4, and y might be -7. Not the scale. Rise over run. So let's go from here to here. So if I start at this y value of -7 and we rise all the way up to this one of +10, how far is it from -7 up to 10? 17. It's a rise of 17. To go from -7 up to the x-axis, that's a 7 change. And then you go 10 more, so 7 and then 10. That's a rise of 17. And then the run, so left and right. So if you're at 4 and up here, you're still at 4. How far across did we run? 0. 17 over 0. 0 goes into 17. I don't think so. Last week, we went over if you have a number and you try to divide by 0, as long as it's not 0 over 0, a number divided by 0 is undefined. Undefined. So the slope of vertical lines is always undefined. Always. Because the x's, when you divide by the x's, difference of the x's, on a vertical line, the x's have to be the same, or else it won't be vertical. That's what makes it vertical, because the x's are all stacked on each other, straight up and down. So if the x's are the same in the denominator, when you subtract them, you're going to get a 0. Always. So you would be dividing by 0. That means it's undefined. Okay. Now, last week I told you this. I told you I would spill the beans about what if. So 0 divided by some other number is equal to 0. A number divided by some number except 0 divided by 0, that's undefined. Now, at some point this semester, on a bonus question, on a test, I will ask you, what does this equal? It could be any time. Don't know. What happens if you get 0 divided by 0? Now, here's the deal. I just got done telling you, if it's in the numerator, it's supposed to get 0. But if you have it in the denominator, it's supposed to be undefined. You can't, on a multiple choice, you can't bubble in 2 answers. You can't be both. So the answer is, I don't know. Honestly, it's called indeterminate. Me, I don't know. Cannot be determined. Sometimes 0 over 0 is 4. Sometimes it's -2. I've seen it equal E. You can't do that problem until you get to a calculus class. It's not about equaling 0 over 0. It's about when something approaches 0 as something approaches infinity or infinitesimal, and the denominator approaches 0 as something approaches infinitesimal. That's when you would get something that approaches 0 over 0. That's where it takes it. It comes from slope. But the bottom line is, because it could equal who knows what, indeterminate, you would have to figure out what are the functions that make it. So if you end up with a 0 over 0, the answer is indeterminate. And it would only ever happen on a bonus question. Okay? All right, real quick. Rise, positive, fall, negative. Special cases are the horizontal and the vertical. The special cases, number 4 and number 5, I'm going to put over there, are horizontal and the vertical. Here's what you got to know. Remember which slope goes with which one. Here's what I hope will help you. The horizontal line has a 0 slope. You cannot spell horizontal without an O, and the slope equals 0. So horizontal is the 0 slope. Don't get them mixed up. The vertical line has an undefined slope in the alphabet. A, B, C, D, E, F, G, H, I, J, K, L, M, P, Q, R, S, T, U, V. Oh, U and V are buddies. Undefined, U, D, vertical. They're buddies. A U almost looks like a V. The U and the V almost, U is just a V with a kickstand. So that V, and that's a horrible V, it almost looks like that. I wrote a U, but my U's look like this. U's and V's kind of look like each other. So the vertical line is the undefined. You got to know which one is which because it's going to save your bacon. It'll make your life so much easier when you got to do the last two, because the last two, there's no work to show. The only thing you could possibly do to make sure you get it right, draw a picture. That would help. Okay, here we go. So the last two, special cases. Horizontal. Five vertical. My penmanship still hasn't reached a consistency yet. So hopefully we can get this week. Horizontal. The slope is undefined. Horizontal, actually, I already mentioned that. Slope equals 0. If I was to plug into y equals mx plus b, if I was to let my slope My m equals 0. My slope is 0. Y equals 0 times x plus b. What's 0 times x? It's 0. I get y equals 0 plus b because 0 times x is going to make x, that product is always 0, which means there ain't no x no more. To speak eloquently, there ain't no more x. And all you have left with is a y equals this number, b. So if it's a horizontal line, it's y by itself. There's no x. Y equals a constant. Y equals just a number. There is no x in the equation. For instance, this person right here, the one that I drew over here, all I would have to do, if I was going to write the equation of this line, this y is a 5, that y is a 5, this y is a 5, this y is a 5. The equation of this line is just y is a 5. Now, I don't care what x is, y is always 5. That's the equation of the line. Y is always a 5. You don't have an x in it because x isn't gonna affect it. So all you have to do is you put y equals 5. If it's a horizontal, y equals just whatever that y is always going to be. If y is -4, it doesn't matter. It's a 5. If y is negative, y is a 5. If y is a 3,497, I just said y. If x is a 3,497, then y is a 5. Y is a 5. So it's just y by itself and y equals some number. There's no x. So when you do the equations of your lines, I left step 2 with a little blank on it. And I wrote, is it a special case? If yes, make a sketch. That's going to help. So we'll come back and we'll show you how to do it. And I'll make sure I move the camera in a second. If it's vertical. If it's vertical. Y doesn't matter. That x is a 4. That x is a 4. That x is a 4. No matter what y is, the x is a 4. This could be, 5.37249. But x is a 4. Y doesn't matter. X is always the same number. X is a constant. So if it's vertical, the slope is undefined. The slope is undefined. And it must be the other one. X is a constant. X equals some number, and there is no y in the problem, in the equation. Okay, so how can we remember which one is which? Well, I came up with this a few semesters ago. I don't know if it actually helps, but you got to figure out a way to remember which one is the verticals and the horizontal, because some people will mix that up, and when you have a horizontal, they'll put the x instead of the y. Because this is, when you see this, You confuse it that the x-axis goes left and right, so you want to put x's for the horizontal line, so that you set up. So here's the deal. Horizontal is an H. So if I spell it with a lowercase h, that lowercase h almost looks like an upside down Y. Almost, if you have a little bit of an imagination. But you got to make a connection in some way to help you remember which one is which. So horizontal is Y by itself. It's the Y. And then the vertical X is like having a V on top of an upside down V for a vertical. Or let's just say that X doesn't even look close to an H. So X cannot go with the horizontal line. X has to be the other one, the vertical. But an X is made out of a V on top of an upside down V, a couple of V's. So X goes with the vertical. Okay. All right. So the last bit of our practice quiz warm-up. I will go a little bit more in detail about parallel and perpendicular on Thursday. Because there's some other types of questions you'll see. But for right now, this is the kind you're going to deal with as your bonus question on next Tuesday's quiz. It's going to look basically like one of these four. Parallel lines are two lines that are basically two coplanar lines. Two coplanar lines that don't intersect. Two coplanar lines that do not intersect. They have, and this is the detail I'm going to give you on Thursday. They have to have the same slope in order to not intersect. Okay, the same rise of a row. The best way to do this kind of a problem, and what you want to do is look at the wording. This is how it's going to be worded. So get used to seeing how this question is presented, and then you apply it to the quiz and on the test. Here's the point 35 and parallel. So it's going the same direction as the x-axis. So how do I know this is a special case? Because if it's parallel to the x-axis is a special case. The x-axis is a horizontal line. So the best way to do this problem, if you're going to show any work, if you expect partial credit, just in case it's right or wrong. Five is in quadrant 1. Goes right about here. This is the x-axis. It goes left and right. So parallel to the x-axis is going to go left and right as well. That's what was just described. And what we just described is a horizontal line. The line they're telling me about is horizontal. So it is a special case. Step one, find the slope. Well, the slope, technically, if I actually worked it up, it would be a 0. And if the slope is 0, that's a special case. It's a horizontal line. So there really is no way to use the formula to make this work. I just need to remember horizontal looks like an upside down Y. So it's just Y equal to some number. What will all the Y's be on this line? They will all equal 5. If this is 1, that's a 5. This is 0, that's a 5. If this is 12, that's a 5. All the Y's are a 5. And that's the answer to the problem. That's the equation of line, Y equals 5. But seeing that it's horizontal will help you make the right choice. I've seen students put x equals 3 because they think it looks like this. And here's the bad news. I've seen students put y equals 3. Isn't that an x coordinate? So how could y be the 3? So now they've got everything jumbled. And now that I put that into your head, self-fulfilling prophecy, so here's, I'm sorry. Don't be the one. Through the point 5, -1. Draw a picture, special case, perpendicular to the x-axis. And again, how do we know it's a special case? Because the x-axis is a special case. X-axis is horizontal. Well, let's discuss, and again, more detail on Thursday. Perpendicular. Two lines that intersect and make a 90-degree, or otherwise known as a right angle. Two lines that intersect and form a 90-degree or right angle. That's what perpendicular is. The x and y axis are perpendicular. Now, it doesn't have to be straight up and straight down, horizontal, vertical. You could have 90 degrees and it can be just turned. And we'll discuss what these look like. That's Thursday. 5, -1. So that's 5, 1, 2, 3, 4, 5. And then down 1. So this is where 5, -1 is. If it's perpendicular to the x-axis, it has to make a right angle and intersect the x-axis, so it has to look like this. This little symbol, this little box that I make right there, that's the symbol for a right angle. That means those two lines are perpendicular. You don't have to put it, but here's the deal about when you draw a picture, you cannot assume just because it looks like 90 degrees that it is. Okay, you never assume when you're doing things in mathematics. Okay, it could be 89.97 degrees for all we know. Just because it looks like it doesn't mean it is. As soon as I put that little box in there, okay, that's 90 degrees. Or you can write 90 degrees right there in that corner, and it has to be 90. So now we know it's vertical. And because it's vertical, we know it's x equal to a number. And no matter where you are on this line, the x is always a 5. X is always 5 on this line, so it's just x by itself, x equals 5. You're done. I have to draw the picture because I have to visualize which one is it. I have to. Listen. And the reason why I have to is because I want to get it right. I don't get partial credit because, well, I'm not taking the test for a grade. But I have to draw the picture because I want to make sure I get it right. I'm a visual person. I cannot read this and in my head make the picture come to life. I can't. I have dropped in on the, on my head as a child. I don't know. I got scared by going to Daniel with those lines, those roads. I don't know. But the bottom line, I need to see. Yeah. The other two, try to go finish it up on your own. And we'll do more practice, quicker practice. And this is, I will have to start kind of going a little bit quicker for those of you that want. Some of you are like going, okay. Good pace. Slow down. But everybody's coming from a different background. I know. I read, some of the stuff that you wrote. I love the comment that somebody said, if I go to hell, I'll be doing math forever. Well, if I go to hell, I'll be writing letters of recommendation forever. Because when I left Buchanan High School, one of the things I was writing 60 letters of recommendation the last year I was there. And I can't stand much. But that's okay. Now my son-in-law wants a letter of recommendation. He was a messy roommate when he and my daughter lived in our house. He never took the dog out. I always made my daughter take the dog out at 2 o'clock in the morning. I don't know what it was. So my wife did that. If I ever talk bad about my wife, personally, I'll appreciate that. Okay, so let me take a roll. I see that practically everybody is logged in to Pearson, which is awesome. There's like one person I think is not in there yet. Make sure you get going to Pearson. Sorry if I'm butchering names, but I'll try to get better. Here we go. Sarah?
Here.
Alan Colorado? Val Diorian? Here. Larissa? Anna?
Here.
Diego? Here. Perlina? Leilani? Coriella?
Here.
Alyssa Gutierrez?
Here.
Julie Gutierrez? Julie Gutierrez? Julia Hernandez? Juliana Martinez? Tony Molina? Skylar Taveros? Lisbeth Ramirez? Linda Sandoval? Monica Simmons? Kylie Tello? And Leticia Velarde? All right, anybody not get called? Great. See you Thursday. You paid online with them?
Yeah.
Oh, let me stop that.